You're listening to the N2K Space Network.
Attention all security professionals. Want real-time IP intelligence at your fingertips? Sign up for Scout Insight's free trial today. Get immediate insights into threats, search any IP with no training required, and enjoy intuitive graphical results. Whether you need to identify compromised hosts or enrich Splunk queries, Scout Insight has you covered. Don't wait. Accelerate your threat response now. Visit teamcumry.com/cyberwire to start your free trial.
Qualifying propulsion systems is a vital step in developing launch vehicles. There are facilities dotted around the United States that offer static test stands, but only a handful that offer ambient or simulated environments. Why is that important? Well, you're about to find out. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. And our guest today is Jaydee Dyess, Director of Test Operations at Agile Space. Agile Space has over a decade of experience testing and qualifying rocket engines and novel combustion devices. They have conducted more than 8,000 hotfire tests on test stands located at their facility in Durango, Colorado. The company says it's committed to producing some of the most accurate and reliable test data available in the industry, and Jaydee explains why.
I started with my career at Boeing, and I worked in production there for a little bit, eventually kind of moved my way towards flight test at Boeing. And there I was responsible for working on pretty much every platform we had. Originally was the tanker, and then I worked 8.7 and 3.7. 4.7, did flight test there, which is super fun because you get to go to Hawaii and test and, be down there. I left Boeing, 2017 or so, and went to Raytheon. And that was actually chasing my wife. She got a job down there. And so I was just looking for work, and Raytheon snapped me up, and they put me in just GSE kind of junior engineering role. I just blissfully worked easy engineering tasks for a few weeks and just kind of lived it up. And then someone finally caught on, and they're like, no, you need to go in here. And so they took me into a SCIF, which is like a classified area. And I started working hypersonics. So I was a principal engineer for the Hawk airframe, which is a hypersonics air breathing weapon concept. So I did the propulsion system for that, thermal management system, isolation scheme, and EMI protection. So I did that design work for a while. We got to where we flew those first few units for DARPA, which is awesome. They went further than 500 nautical miles and at least Mach 5. That's about all that's unclassified of those missions. And then the next step after that was going back to production again. And man, no interest in that. I knew the guy who started Agile and some of the other earlier people, and they've been kind of keeping me in the loop here. And so that was kind of the right time for me to move out of Raytheon and come and try something different. So then I came to Agile. That's only been 2 years now. But came in and just started immediately kind of working with the design teams, the leadership teams, and kind of figuring what I could really target for them. And that's a lot of what I brought to the table was big aerospace projects and concept design in a rigorous way, but also fast. And that's a lot of what we do here is super fast. So then I came here and started working in our testing facility. And been just kind of, living it up, testing rockets now. Learning new tech myself and then helping kind of teach people here what I know. It's been super fun. The crews here are great. And everything we do here is really, really fast-paced. But yeah, super fun.
Oh my gosh, that's so cool. And now you're the Director of Test Operations. So what can you tell? What is your day-to-day like? What do you do?
Day-to-day is usually scrambling because schedules are constantly moving. And test is one of those things that I've always considered the end of the whip. If you've got a bunch of schedule margin, it's always eaten up by the time it gets to test. And so then they get to us and they're like, hey, you gotta still hit the window. We need you to finish testing by yesterday. And usually you can't do that. So a lot of it is trying to figure out what do they really need to be done, how fast you need to do it. how rigorous are the requirements, and then organizing the team over there. And we have 2 test stands. One of them's older, Sunshine is what it's called. They're all named after mountains. So we have Sunshine and Animus. And their first one was built to be torn down on trailers. So it's all these custom modded trailers that you could tear down, take to Mojave, set back up, and test. But we don't do that anymore. That's when we used to test for external only. Once we started doing our internal design development, we test our own stuff. And so it all stays here in Durango, which is awesome. We're at 6,000 feet here. So our altitude systems get some efficiency bump from that, from being higher altitude, which is great. But that's not the reason they did it. It's mostly because it's beautiful here, but we just get the added benefit of having the altitude system. But yeah, maintaining those 2 stands is the big part of the job, and kind of getting through the testing campaigns. I think right now we're testing 4 different kinds of thrusters, and we're kind of alternating them on the 2 different stands. And they're all hypergolic in some way. So they either use like a hydrazine or a monomethyl hydrazine, and then usually mix that with an oxidizer like a MON3 or a nitrogen tetroxide, effectively like an oxidizer or oxidation level of a nitrogen. And then we run them through the test stands, which are motive gas systems, which are just really big rockets. They're big cold gas thrusters that help simulate the vacuum of space. So, we test all these things in a vacuum to some extent because the heating profile is a lot different. When you're in space, you can't, there's no convection. There's no way for the heat to get out except for through radiation. And if people are testing that stuff atmospherically, which you do, you don't really get a good idea of how much heat soak back you might get into the system or the vacuum start. So we use, our test stands are set up like a 2-stage motive gas system. So we have massive nitrogen storage. We have a 6,000 gallon liquid tank and an 11,000 gallon liquid tank. And then we pump that through a vaporizer setup. So it takes the liquid gas, our liquid nitrogen, turns it into LN2 to liquid nitrogen. And then we pump up tube trailers and ground storage to 2,500 PSI, pretty high. And then we just let it rip. The whole thing just blows down through a regulation system that, fires through our altitude system, and it acts like a big Venturi. So it sucks all the out of the air out, and the thruster that we're testing can fire into a cell and have all the nitrogen actually take all of the gas from the exhaust out of the thruster and still maintain a vacuum. And usually those are 0.1 PSI. So in the vacuum, so a few 100,000 feet, which is pretty good. NASA and some of the hard vacuum stuff, they're testing into micro torr. We're at 5 torr, which is still pretty good.
Sorry, you just explained something that I've always wondered how that worked. I'm just how do you do that?
How do you get that lower torr?
Well, no, but how do you do the kind of testing you're talking about while replicating a vacuum? I mean, you can't put that in. Yeah, I'm sorry. It's a basic question, but that's been something that people ask me, and I'm going, that's something you just explained it. Thank you. I've been wondering that for a while.
It's very basic. To me, it's really cool, and there's not a lot of people that do it. White Sands does it, but they use steam generation, and so their system, it can run for longer, but they can't turn it off. Right, so you start a chemical steam, and that system is the same thing, right? Except for the motive gas is steam, and then they can get a benefit out of the momentum by taking the water out. So they push steam through at high speed, and then they have a condenser that then recovers the mass of the water and then can help speed that flow up. We don't use chemical steam here for a few reasons. One of them is it's really difficult to power it. It takes a large amount of power to heat water. But then also you can't turn it off. Ours is a nitrogen system that has a gas blocker and a bunch of other kind of valving. So we can turn it on and do a 5 millisecond pulse and then turn it off. So we have a startup period of 10 seconds, do a pulse, then let it shut down. And so it's 20 seconds total. And there's a 5 millisecond pulse in there. With a steam generation system, you just turn it on and then you route the motive gas over the thruster. And when the thruster test is done, you route it away from the thruster, but you're still generating motive gas. And so it's $200, $300 a second that they'd be generating. With a nitrogen system, we can just turn it off. It's still pretty expensive, but we can just turn it off. Maybe a test fails and we need to stop it, or we need to reevaluate and stop it. But yeah, the motive gas system, you could turn them on and off and kind of flow through it. But like we are capable of pushing, one stand right now is pushing 25 pounds of nitrogen a second. The other one is doing about 40 pounds a second, but it can do up to 100 pounds a second.
Is that the newer test stand? Yeah, I was going to say, that's got to be the newer
test stand, Animus, yeah. So Animus is, we just commissioned that in March. It's wild, right? So Agile built it. It was an atmospheric test stand, which means it just had a thruster sticking out the back of a Connex, and we just fired it outside.
And it always looks cool.
It looks great, right?
Always great.
Atmospheric testing looks the best.
It does.
But atmospheric also has a lot of issues with it. But we took that atmospheric stand in May of last year, moved it over to a new site, and then built a whole altitude system and finished it by March. It's a huge stand. It's got a 100 foot by 110 foot concrete pad. We've got 2 tube trailers parked on it that are 146 standard cubic feet of gas, and then a big ground storage tank, big 11,000 gallon nitrogen storage. And then that blows through, right? And it's got 2 containers, like shipping containers, laying one direction, and then on top of that, orthogonal to those 2, is the top container. And that's where the cell is. And that at height allows us to have that altitude system. But that's got the fuel storage is there, the motive gas, the nitrogen is there, and the propellant storage is all there on that one site. But yeah, that's the newest one. And it can do instrumentation channels up to a megahertz. Primarily what we do is like a couple hundred kilohertz, but we can do down to a megahertz, or up to a megahertz, I guess.
We'll be right back after this quick break.
This September 18th and 19th in Denver, a tight community of leading experts is gathering to tackle the toughest cybersecurity challenges we face. It's happening at MWise, the unique conference built by practitioners for practitioners. Brought to you by Mandiant, now part of Google Cloud, MWise features one-to-one access with industry experts and fresh insights into the topics that matter most, right now, to frontline practitioners. Register early and save at mwise.io/cyberwire. That's mwise.io/cyberwire. The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
I mean, who you all are testing for, the kind of testing you're doing, and also the kind of applications, it's got to be pretty wild, cutting-edge stuff, given what you all can do.
Yeah, exactly. So we've got all the additive stuff in-house here, so we can make our own, we can make other people's thrusters, slap them together, depending on how quick they need to be, if it's a really rigorous program or like a dev campaign. I mean, we did 1 clean sheet design, 2 test stand in like 6 to 8 weeks, I think. So clean sheet thruster design, we built it, we fabbed it. We got it on the test stand, we hot fired it. And that was for a client that I think had some extra money towards the end of Q4, and they just needed to get through it. And so they turned us on in like November, and we hot fired before Christmas.
Wow. So the company name is really apt, is what it sounds like.
Yeah, Agile for sure. Agile for sure. Yeah, we ripped through stuff pretty quick. Like I said, right now we've got 4 thrusters that we're trying to test on the 2 stands right now. And the test team's there's only 7 of us. There's 7 people out there, and we you get to have a lot of fun. Like I'm the director of test, but I'm part of the test team as well. So we're not a big enough team to where there's like you're not doing the work. And then we're in Durango, so it's super hot this time of year, but it's also snow. So everybody will be out there. We've had like hot fire tests during a blizzard. It's just like white out snow coming down, but it's great. The wind is good, and we need the wind to kind of blow plumes and stuff away. But yeah, so we'll be tested in a whiteout blizzard, but then you also got to go and shovel the pad so that you can make your way to the test stand.
Well, you wouldn't do it if it wasn't fun as heck.
Yeah, I mean, some people were
Yeah.
asking to get out there to be tested during the blizzard because they could say that they did a hot fire in a blizzard. It's not a lot of places you can do that. Most places are like in Midland, Texas, or in Mojave. Here, we get all the seasons.
That's so awesome. I was going to ask you've been there 2 years now. You've got to have some favorite stories of, some really fun tests that you've done. Or, hot fire in a blizzard sounds like one of them. Any others? I'm just asking for war stories, basically. But
yeah, we've had a few interesting ones. We had one one thruster that came apart in the cell, and it made a huge mess. And that to me, it's not super fun because it made a big mess. But at the same time, you kind of get to see a very dynamic test where things kind of fail, and then see kind of all the safety guards that are in place. And to me, that's really what I get. I get a lot of kick out of, a lot of fun. Is like you see something that's just like, oh man, that could have been really bad. But the systems are in place, and the teams kind of react to things very calmly. That's something I've always liked about test. So that unit specifically came apart. The abort sequence was initiated, the test stand came down, and then we just had to go clean up and get back to test. And we really didn't lose that much time. And that I can't talk about specifically the client that one was for. But that's just one of those cases where it goes really well. We had another thruster on our bigger test stand that had a controller failure that just resulted in a release of some propellant. But it was still in the system. Like we had a catchment system that prevents any of that from getting out. And so that's another one where it's just like, oh, a failure. But it was absolutely not an issue, which is kind of fun. We have other thrusters. We had a thruster when we were an atmospheric test stand, and it was a biprop, but it didn't mix, which was bad news because it just like Neapolitan out of the back of the thruster. Like you could just very clearly see the two colors.
Little layers.
Yeah. And in the middle, there was a little bit of fire. But
some strawberry in there. No.
Yeah, right. It's just like a very, very beautiful color scheme of death. We were able to safe that area as well, and the winds were appropriate. Like there was a HAZOP associated with that being acceptable to test it that way. But the problem with an atmospheric test stand, like I was telling you before, is that also resulted in that entire test stand being contaminated. So the oxidizers, they just go away. That one kind of resolves itself. But the fuels, they stick and they're kind of wet. They almost look like water. And so the cleanup for that takes a lot of time. And so our test team then has to go down an SCBA, which is a self-contained breathing apparatus. And so it's like what a firefighter wears. It's a full face mask. You wear PPE, big suit. It's very hot. And you go down there and you have to you either put Zine Clean on it, which is a chemical that'll neutralize hydrazine, and then you clean it off, or you have to clean and capture in a sump system to then ship all this stuff out. And everything you're cleaning up is dangerous. So you're in PPE while you're cleaning it up. And, it's when they're in an atmospheric test stand, all of the pipes and tubing, everything gets propellant on it if it blows back into it.
Oh,
and so you're wiping these things down in a paper towel or, we're not going to that is flammable, but you're wiping it down with appropriate kind of, Ken wipes and, washing everything with water, capturing all of the water. You can't let any of that go. You capture all the water in sumps, and then you have a hazmat service come and clean it up. And then they charge you by the pound to pick it up. And so when you have that atmospheric test stand, they can be really cool. And when they work, they're great. But if you do have that one where it just didn't mix, then it's a bit of a cleanup that has to go through. But again, it's one of those they're troublesome. But it's a great example of when you have a test crew that is comfortable and calm, they can really navigate any of those things. If you go on YouTube and you go and look at people that are testing hypergulls in Mojave, there is a plethora of videos of people falling down and scrambling away from a red cloud of death because they just didn't have the appropriate setups or reliefs. Here, our system is robust. We've been around for a while. We've been doing even when we started in 2010, right? We're not a startup anymore, I don't think, even though we still kind of have that mentality. When we come across some of these scenarios, you can still have a fun war story because nobody was hurt. The stand wasn't damaged. It was just a big cleanup. And you got to see something go wild on a screen or an image. We're all remote. But seeing an engine come apart, rud, or seeing a, not mixing, Those are exciting, even though for a test engineer, generally you don't want exciting, you want boring. Ideal test day is a boring day. But when somebody else is coming to view and they're, just want to have some fun, they can really enjoy seeing something come apart.
But not so fun on the cleanup when you have to get in the hazmat suits.
Yeah, and it's hot. Like if something ever goes wrong, it's never like a 70-degree day. It's either going to be a 20-degree day or a 90-degree day. Those are your choices. It never goes wrong.
Heed that warning, everybody.
That's like you just plan on it. If it's an extreme heat like wave, something's going to break, and you're going to have to go clean it up in PPE because Murphy's Law.
Of course. It's good to know. And, whenever I'm out there visiting, I'll make sure that it's not a hot day. I'll be really careful, and I'll be like, "So
spring.
Can we see something?"
Get here in spring.
Yeah, spring.
It's perfect.
There you go. That sounds great. A lot of your reflections have been really cool about sort of the nature of test, and I feel like that's so valuable also for people who are, either making a lateral move into that world or thinking about it themselves, or maybe just people who are in it already. And I don't know if you have like words you want to share with them or people, or I don't know.
I mean, something that I say around here a lot is like test you must all the time. Like you can't do anything without testing, no matter how much you get into it, analytically. If you throw the best CFD at it, you do the best, kind of sample work or even prototype testing, like until you actually try it, you never know. Like until you actually take an empirical measurement, everything is not for sure. And I've seen that at big primes like Boeing. I've seen it at Raytheon, and I've seen it here. Like, I don't know how many times I've had someone come to me and say like, oh, this is going to work. It's going to be fine. Here are all the reasons why it works. Here are all the peers that it's been reviewed by. Here's, somebody with a PhD who says, yep, you're totally gravy. No problem. And then you go and you put it through its paces and it blows up. Or it doesn't blow up, but something weird happens. And, say we have a regen channel and it doesn't work and it burns. And they were like, oh, I didn't know about that one thing. So generally the advice I ever give to any engineer is always plan to test it. Test. And right now, space is really moving towards a very risk-tolerant approach. Get more into space. And there's some of that like test in space mentality, which I'd love to do. Like I'd love to build a test stand on the moon, and then I can really test in a vacuum. But the clients and everybody needs to know that they've got to plan on testing. And one thing I kind of teach all of our junior engineers, or even just people that are new to it, is plan on a few design cycles. And plan on having to go through and have learnings. You're going to find something you didn't know before, and you don't know what it is, but you can still plan to learn something you didn't know. And then your schedules become a little bit more realistic, and you don't have like the morale slam when you all of a sudden you're like way behind schedule. That's generally, you got to test, and you got to plan for learning.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazis. Thanks for listening. We'll see you next time.